Okay, so this is video number 2 for the RayPak wiring diagram. So you've looked at the factory diagram from RayPak, and here it is here, really kind of hard to follow and understand. So you've made your own hand-drawn version of this, which is a ladder type diagram where you can go through and do the logic sequence of turning on the power switch, make sure the low water cut off. So this is a lot easier to troubleshoot from something like this, and this may be something that you need to do in the field, and you will be doing in the field sometime in your career, is you'll be looking at a diagram and it doesn't really make good sense the way it's laid out, so you start to redraw it in a fashion like this to where it actually does make some logical sense, and you can go top to bottom, left to right, and make some sense out of it. That's kind of the whole idea of this. But once you get your drawing done that looks like this, you're going to submit it. So going back to the main page, this tab right here says submit your drawing. You're going to click on that, and you're going to find the file on your computer, and you're going to attach the file, which is a picture of your drawing. So I assume most of you, what you'll do is you'll do this on a piece of paper with a pencil, nice and neat. You'll have your drawing. You'll take your phone, you'll take a picture of your hand drawing, and then you'll save that to your phone or save that to your computer. Sometimes it's easy to take a picture file from your phone, email it to yourself, and that way you have it in your email as a file that you can save on your computer. And then once you're done, you come down here, browse local files, and you find it on your computer, and you'll see that the file will show up here, the name of the file, and then you click submit, and that way I'll be able to see your hand drawing, and I'll be able to grade that. That'll be 50% of your grade. The other 50% of your grade will be from probably 10 questions that I'll put together based on the first video and this video as to the function of the solid state economaster, the low water cutoff, the ignition control, things like that. So here is the RayPak manual, and the first thing I want to do is I'll scroll down here to page 25, because the whole purpose of the redrawing this was to understand what a solid state economaster is. And I think that the term solid state economaster is something that RayPak made up so that they could sell this for $100, and really it's just a time delay relay is all it is, and it tells you that right here, economaster time delay relay. And it has a little dial here that I believe, from what it says right here, the time delay relay allows you to set the delay off time from 3 to 10 minutes. Factory set at 7, as a max load of 3/4 horsepower, which is for the pump. But a time delay relay would do the same thing as this. I don't know that you always would have to buy one from RayPak, but that's really all a solid state economaster is a off delay type relay that keeps the pump running for 7 minutes after the burner shuts off. The next thing I want to go down to is page 31 here. I'll talk about this because on this particular burner, it's called an atmospheric burner. You see right here where it says figure 35, typical main burner flame for an atmospheric model. So that means that this type of boiler does not have a blower. It doesn't force air into the combustion chamber. It doesn't have an induced draft motor. It was considered atmospheric pressure. So it has what's called ribbon burners. And here they're showing that the ribbon burners should not have more than a 4-inch tall flame maximum. But this is pretty typical for a smaller light commercial residential type boiler. And cleaning those ribbon burners is an annual maintenance kind of thing. You typically would want to do that in the fall. Pull the burners out, take a wire brush, take a shop vac or compressed air, and get them cleaned out. Okay, further on in the RayPak manual here, you'll see a picture of the pilot assembly, and I'm going to go over a little bit about the Honeywell ignition control and some of the differences in different models. But this one here, you have the actual spark igniter, and it's sparking to this hood. Here's where your pilot gas would be coming in, and this would light the pilot gas, and it would come up and hit this shield right here, and that's kind of a grounding shield. But this probe right here that sparks and lights the gas is also the sensor. So it's a combination spark and sensor all in one. You'll see down here on some of these drawings, now I did not use the drawing from this manual. The drawing I had was from an older manual. I couldn't find it online, but this one's going to be a little bit different. The closest one to it is probably this one here. This one would be fairly similar to the one we just did, and again, here's the boxes. Well, I guess that one has high and low gas pressure, so maybe that's not the closest one. But you'll see on all of these drawings, from the spark terminal on the ignition control, it says it's a high tension wire. It should be a thick insulated, usually silicone type wire that goes to the ignition. And I think it's pretty important to see that they're showing this actually has to be grounded. And you'll see right here on the ignition control, it has a ground terminal, which also has to be grounded. That's probably the biggest thing that causes ignition failures on this type of ignition control, is that you don't get a good ground from the pilot assembly to the ignition module. And if you don't have a good ground there, or an actual physical wire that goes from this point to this point, then you're not going to get a good flame signal reading, and that would cause you to have a intermittent flame failure problem. So this here's some troubleshooting information. So I'm going to use some of the things in this manual to put on the quiz. So take a look at some of the things here. There's a couple different wiring diagrams, but I will try and focus on the function of the solid-state economaster device, which was the main purpose of this. It's a time delay relay, and the fact that this is an atmospheric type burner. Here you see the dual gas valves, the pilot gas valve there. Here's the pump. Here's the flow switch. So close that and go back. And one other thing I put on here, here's the two types of ignition, Honeywell ignition control documents. This one is for the S8600 or the S8610. You see here that when it says igniter versus sensor, igniter sensor type, some of them can be separated where you have a separate igniter, separate sensor. Some of them are combination, like the one we're talking about is a combination. So the S8600H is probably the most common one you see here. No pre-purge, doesn't have a blower. It's an atmospheric burner, so it doesn't have any of that. It will spark until it lights or lock out. Pilot valve closes on lockout, so you don't have pilot gas. But the way that you reset these flame safeguards when they fail is to cycle power. That's the only way to do that. Now, on most of these or all of these ignition controls we're going to look at, the main valve and pilot valve are powered with these three terminals. Here's the ground that goes to the pilot burner. Here's the high voltage spark terminal. And here is the 24 volt ground, 24 volt hot. That's the power that comes from the transformer. This one uses a single spark. They do make models that have a vent damper plug. If you have a vent damper, which is a motorized damper on the flue gas vent, I never thought it was a real good idea, but they do it. Here's a model here that has a separate spark and sense. So you actually have a flame rod and an ignition igniter. So there's different models of the Honeywell. This was the S8600. Let me go back and open the S8610U. And the thing about the U is universal. So S8610 is a U, it's a universal. If you went to the supply house and you needed an S8600H, 8600H, and they said, we don't have that, but we have this because this is a universal replacement. Well, you look here, here's all the models that it replaces, and there's an S8600H. You know, there's all these different models, including the Johnson, which is the G60. I'm sure Robert Shaw, Pan Johnson, you know, all these different manufacturers, including Fenwell. You know, this Honeywell S8610U is a general universal replacement. Some more drawings. Here's where they use spark and sense, and then there's other ones that are just single. Like right here, you don't have the sense, you just have the spark. And at the end of this manual for the Honeywell S8610U, it gives you a little bit of information like you saw with the flame safeguards, where the internal circuitry and how it controls the main valve and pilot gas valves. Okay, last thing to go over, and then I'll make up, like I said, maybe 10 questions. Each will be worth 5 points, and that'll be the 50% of your grade, or 50 points of your grade will be from the quiz. The other 50 points will come from the drawing that you do by hand. Last thing I want to talk about is the hydro level safeguard. And I want to do this because I pretty much have told you on everything else that the McDonnell-Miller Model 750 low water cutoff was what they use on, I think, all the other boilers that we've looked at, or diagrams that we've looked at. But this one, I know for a fact it is the Hydro Level. The company name is actually Hydro Level Company. I know it uses theirs because when you look at the terminals on the diagram sheet, or excuse me, the wiring diagram, pictorial diagram that comes from RayPak, it says that the contact terminals are P1 and P2, and you can see that here. So this is something I want to put on the quiz. I'll probably ask a question about the wiring method, because here it shows wiring method A, same power source for control and burner circuit. And when you look at our drawing here, you'll see that the same power that comes to H feeds down to P1, and that's what they're getting at here. The same power that comes to terminal 1 here, which is the hot terminal, also goes to P1. There's the jumper right there. So basically you're only using 3 wires. You've got your neutral, your hot, and then hot jumpers over to P1. P2 comes back, and on our drawing, P2 goes to the 120 volt side of the transformer that energizes to give us our 24 volt circuit. So that is the method for using the same power source for the control and burner circuit. And method B, you use a separate power source. So here's your 120 volt power to power the electronics in the low water cutoff, but here you use a separate circuit for the P1 and P2, and I don't know that it even has to be the same voltage, because you're just isolating, you're using just the P1 to P2 contacts. So the 2 different methods are actually, here's the third method, but the difference between method A and B is whether you use the same power for 1 to power P1, or you use a separate power to P1. This talks about the dimensions and the probe, and a little bit about troubleshooting if you lose power. Here this is pretty important on installing that probe. This probe here, you screw it into the side of the boiler or into a fitting, and it tells you that an excessive amount of Teflon tape can keep it from reading to ground. So it's pretty important that when you put Teflon tape on there. Don't overdo it, and make sure that when you screw it in, that it does make a good connection. And here it talks about the lights and the 30-second duration and time for the manual reset to take effect.